Welcome to the ESO Supernova Visitor Center and Planetarium. My name is Wolfgang Vieser. I am Education Coordinator at the European Southern Observatory, ESO, and responsible for the education program at ESO Supernova. The ESO Supernova is not only an astronomy center for the public with a state-of-the-art planetarium and a huge exhibition floor, but also an out-of-school learning location that attracts approximately 9,000 pupils a year, like this group from Poland. The exhibition, The Living Universe, features 13 themes covering the science and technology behind modern astronomy. All content is provided in English and German and starts in our foyer at the Wall of Fame, where the flags of ESO's member states are visible, and also our partners that support ESO Supernova. And here we are, the entrance of the exhibition. 2,200 square meters are waiting for you to be discovered. And at the very beginning, we are explaining the importance of astronomy for society, and ESO employees explain how they got into science and technology. We then leave the Earth, set foot on the ground of the Moon, and have an interactive look back on the half-sphere, where we explain how the Earth looks like when observed from the Moon during daytime and also in nighttime. We can also have a closer look of the Moon itself. And the exhibition floor is packed with information presented in different ways, like interactive digital exhibits, like the ones explaining night and day, seasons, moon phases, eclipses, and many more. We have panels and touchscreens so that the visitors can individually choose the depth of information. We have video and audio clips, as well as hands-on exhibits like this one that make the visitors feel the gravity on the various planets. Models of the planets hanging from the ceiling give the visitors a feeling of the different sizes of the objects in our solar system, and the Sun, on the same scale as Jupiter, would just fit into this room, the ESO Supernova Void. In this presentation, I'll focus on how we're trying to make a school visit to ESO Supernova a long-lasting learning event, not only with the takeaway message "Science is fun", but also with ideas and guidance for projects that the pupils and teachers can take home or back to school. So a school visit to ESO Supernova includes at least a planetarium show and a guided tour of the exhibition or the ESO headquarters. And if time allows, we also offer inquiry-based workshops in our seminar room. And here you see the seminar room ready for welcoming either a school class that wants to find out more about optics in the context of telescopes in the workshop Catching Starlight for 10 to 15-year-old kids. We use daily life materials that you find in do-it-yourself shops like plywood, drain pipes, magnifying glasses, mirrors, laser pointers, and so on. Or a school class that wants to find out more on electromagnetic waves in the radio workshop Seeing the Invisible. Here we use commercial set dishes, Arduinos, for finding out what's hidden behind the black covers in the distance. There are many studies indicating that there are long-term impacts of museum experiences and that learning actually happens in a science center, although a lot of research needs to be conducted in this area. We believe, and feedback from teachers support this, that ESO Supernova's education program has a positive impact on the attitude towards science and on the motivation of students. It helps correcting pupils' misconceptions and activating learning processes. Unfortunately, we have not yet been able to conduct any evaluations on that, but the positive feedback and the continuing number of requests for the education program lead us to conclude that our education program has a positive effect. But one takeaway message of all studies is multiple visits or post-visit projects at school are helpful, if not necessary, to lead to effective learning outcome. In order to ensure sustainable and long-term learning success, our workshops are designed according to the principles of inquiry-based learning to gain higher student satisfaction and engagement and to improve retention rates. The workshops were developed in such a way that they can be built with everyday, inexpensive and durable materials so that the students can build them themselves at home or use them at schools. The workshops can thus be upgraded independently, and what was learned at ESO Supernova can be repeated and elaborated later on. The aim of this workshop is to find out more about lenses and how to characterize them without using calculus. The pupils work together in small teams and discover the principle of the focal length by bringing together the results of their groups. And when experimenting with lenses, additional effects can also be studied, such as why an obstacle in the beam path, like a secondary mirror, does not lead to a hole in the image. A nice example of an activity that enhances scientific understanding via the method predict, observe, explain. And with a laser cannon, which generates many parallel laser beams, the learned principles can be reviewed and the focusing of light can be recognized as a three-dimensional process when the laser rays become visible inside the light ray block made of colored synthetic resin. The modularity of the design allows to investigate different setups and telescope types. It's easy then for the students to come up with their own ideas and just try them out. So far, we have realized the refracting telescope, the reflecting telescope, and the Newtonian designed telescope. So far we covered curriculum relevant topics with the overarching theme optics and put them into an astronomical context, since astronomy is a very motivating context. Nevertheless, it's not extremely motivating to use first-generation telescopes if you want to engage students with optics. So we designed an additional activity to make students familiar with a very modern telescope technology, namely segmented mirrors and active optics that are used in ESO's extremely large telescope. Its almost 800 hexagonal mirrors will form a primary mirror of a diameter of 39 meters. It'll then look like the full-size mock-up on the left, made of 798 cardboard hexagons, each around 1.4 meters across. So in the workshop, pupils need to bring parallel laser beams coming from the left with the aid of 6 flat mirrors into focus. And this is how it may look like or can look like. And also here, the path to reach the goal is not specified and different results are possible. Pupils can also try out different ways of focusing the light. They can use the Cassegrain focus and the Nesmith focus as well. And in the end, we have all 6 laser rays focused in one spot. The whole catching starlight activity lasts about 1 to 1.5 hours and is very popular also for teacher trainings. The worksheets and construction manual can be downloaded from our website, so you can try it out yourself also in your school. But you're also very much welcome to visit ESO Supernova. So what's next? We'd very much like to evaluate our workshops or our education program in general. We can gather a lot of data, but that's not the issue. The bottleneck is the analysis and evaluation of the data, for which we don't have time so far, since we're doing the workshops. We so far have 6 workshops ready for different age groups, but already have ideas for more, since the workshops are perfect tools for engaging pupils of all ages with science. So thank you very much for your attention and hope to see you soon at ESO Supernova.